G'day everyone, today I'm going to be building an Acebott Spider Robot. This is a really exciting kit because it is actually one of the most complex robots I've ever built, and I've already been testing this on my students in class for a few weeks now. And this is not like Lego. This is actually like fully complicated, and it's a real robot. So it says it's for kids 8 years and over, and I'm going to take you through the build process. If you have just joined the channel, and welcome, you can comment and chat in the chat area. So if you have any questions, feel free to come on and ask. We have some helpful people from Acebott who might be coming by as well to answer any of your questions. I'm just going to see if I can get my table set up. All right, so here is the Acebott quadruped robot. Just going to get rid of my thing there. Okay. So first thing you got to notice is that you open the box and there are. Can everybody hear me? Okay. First thing you notice when you open the box is that there's a nice little card, so you can visit the website and tutorial links, get all the information you need in order to build the robot. This is the parts list. You can see that the parts are all quite standard as well. So other than the Spiderbot shield, everything else is pretty standard. So you can actually get replacement parts easily. So Acebott sticker. Got a whole bunch of motors. Got some standoffs. Just going to close my window a little bit. Okay, this is the Spider shield. More motors. We've got 8 motors on this robot, so we've got 2 motors for each leg. Lots and lots and lots of servo motors. Here is the 8266, I think. And then a bunch of frames and a USB-C cable. One thing that this robot does not include is a battery. So the battery is a little bit non-standard. You'll have to get it from a specialist battery store. I'll also provide a link maybe to an Amazon link later on. I'm just going to load up my instructions. Maybe I can also show my instructions at the same time. So today my goal is to at least get the spider built, and then if we have time we'll also do a little bit of coding. 8266, now where is that? Here we are. This is the ESP 8266. It looks like. Here we are. Cool thing about 8266 is that it already comes with Wi-Fi, Bluetooth. I think it's got Bluetooth already. It's got a nice and handy communications and charging port and the USB-C. Very cool. Might zoom in a little bit more as I build. Is this enough? This might be enough. Here's the motherboard for the Spider. It's already switched to on, probably have to switch it off. Alright, let's see our next steps. Let's get our spider body parts. So Acebott is a company that designs these robotics kits for education, and they have lots of different robots. So Spider Robot is probably the most interesting one to me because I like, well, actually I don't like spiders, but I do like robots with legs because they look cool. And you know, you see all these robot dogs and robot spiders, and you think they're like these really complicated machines, and they are, but you know, this Spider Robot kit is supposed to teach you all the basics and make it so that it's not so confusing and not so daunting anymore. One thing you're gonna notice about these nuts are that they're really small. So you'd want to make sure that your kids are really mature when they're working with these, because you can lose these really easily if you're not very organized. And also it's very easy for things to break. You see these little pins, they're all exposed. It's not like like a Lego piece, you know, that we can like bash around. These are like professional equipment. Alright, so how does this go? I'm gonna get this and this. Okay. Plug it into there, and then we need our standoffs. Pillar round head screws. A couple of tools that you probably need. So the set comes with this little screwdriver, this Phillips head screwdriver, but I also brought along some needle nose pliers and some cutters as well, in case I need to cut any of the zip ties. Yep, this looks like it's the right one. I'm just going to screw these in by hand. Just make sure we're sense checking ourselves. I don't want to commit to screwing on too tightly until we are absolutely sure of where all the pieces are supposed to go. Now we go in opposite corners first. Feel free to comment if you have any questions, by the way. I know that, you know, watching someone build a robot is probably not as exciting, as riveting as building one yourself. And actually, Acebott has a full build video on their website to build this robot, but it's not like talked through the way that we're sort of doing it now. Okay, this is really good. Really important to keep these pins nice and protected. So don't. Oh, hold on. There's a piece of plastic here, I think. Is there plastic? G'day, Harry. Nice to meet you online. So you can see a preview of the robot that you're going to build on Friday this week. Because this Friday we're going to try to build this robot as well. Alright, so now we need to install our servos. So a servo motor, these ones over here, these actually have encoders inside as well. So they not only know their speed, but also the angle that they spin at. So these motors look like they just go through here. Now the screws to mount the motors are small, but they're not even as small as the nuts, which are M2 nuts. They're very small, and you require a lot of patience to put them in. Otherwise it can cause all sorts of trouble. So here we just got to make sure that the axle of the motor is on the outside of our robot. So this axle is facing the outside. Put this this nut, this bolt over through here, and see how little space there is here. It's a tiny amount of space where we can work with. So I'm gonna need to grab the nut first. Use needle nose pliers to excellent. Thank you so much, Hai Peng, logging on from Acebott. So Hai Peng is an engineer from Acebott. Feel free to ask him any questions during the stream if you have a question for Acebott, who has kindly sent me these robots. So you can see here, I'm using, oh hold on, I'm using some needle nose pliers to try and screw this in. So you'll need a bit of table space. Whoops. That's the easiest way to screw them in, but it's not easy. It's the easiest way to screw them in, but it's not super easy because they're so small, and the amount of space that you have to work with is very small. Here we are. So what I'm doing is I put the bolt in, and then I grab the nut like this, put the nut in the path of the screw. Okay. All right. Do that for 3 more times. So hi Peng, can you tell us a little bit more about the spider robot? Maybe if you're on the chat, maybe you can give some fun facts about the spider robot, what you can do with it. I know in the start we had the coding development environment up for a little bit. You can see that you can code in Scratch. You can also code this in text-based coding languages as well. Just realize I'm too low. Okay. Okay. Thank you, Acebott, for bringing an engineer along to the chat as well. If you feel like chatting with Acebott, feel free to send a message in the chat. I'm sure they're watching keenly on my build, and they can probably see I hope I'm doing well. I hope I'm doing well. Yeah, I watch my students do these all the time. And I feel like they probably build faster than I do. But, yeah, I want to make sure it's correct. That's one. I'm going to be very gentle with these servos and their wires because they're very easy to damage if we don't be very careful with it. G'day. So somebody asked if this is my own design. So this is designed by Acebott. Acebott is the supplier of this kit, and actually they supply lots of educational robotics kits. And this one is probably one of the coolest ones, I would say. The coolest kit that they have. Because after you build it, you can actually control the spider using a mobile app as well, which is so cool. The Acebott Spider Robot actually built. Well, I want to live stream now because it's some students are going to be building on Friday, and I want to be able to show them any tricky parts here before we run through that class as well. And you know, it's fun as well. You know, seeing a robot built is really cool. Can it be synced to a controller? From what I know, it's a mobile app. Yeah, so if you download the Acebott mobile app, you'll be able to control this using the app controls. So it's sort of like a controller, but it's not like a video game controller. You can probably, if you're very, very smart, make an interface for a PlayStation controller or something like that, but I don't think there's an out-of-the-box solution. Correct me if I'm wrong. If anybody from Acebott is on chat, they can probably answer you on that one as well. All right, so we got all of the shoulder motors done. See the next part. Yeah, that's right. So Harry was talking about building his own controller with Lego Mindstorms, which is really, really smart. Right now there's a library called Pybricks, which can be good for that as well. I just mounted the ESP onto the servo extension. I'm just not sure if... Oh yeah, I think it's already gone all the way through. Just don't want to be too hard on it. Okay. Okay. So here we got to make sure that each cable has the brown cable facing the outside of the robot. Like that. Just triple checking my cables to make sure that they're going to the right place. Yep, that is an ESP32. It is a 8632, I think, if I'm not mistaken. ESP 8266, sorry, 8266. Let's get my numbers mixed up. Okay, so there's no kind of screw holes to screw this 8266 down, but I think it's supposed to be like that. All right, let's continue. Now I'm going to try and connect with some legs. I'm going to get some joints. Some claws. I don't think you can connect to a Mindstorm. I'm not sure though. It does have Wi-Fi connection, so I think there is potential for it to be upgraded. What is this? Not necessary. Okay. Let's try to find the right parts. Oh, that's a motor. Okay, gotcha. All right, here we are. Motor. Let's build the front left leg. So I need to go like that. The motor is going to go on over here. Front left leg, okay. Round head screw. Yeah, the building instructions are on the Acebott website for the Spider Robot. If you go onto the Acebott website and the link in the description, you'll be able to see the link for Acebott, and then you can download the instructions there. Huh. Where did I put my? Here we are. very delicate, just getting it into these gaps. Oh, that's an awesome idea. You could have a bunch of dancing robots. I think that means that, you know, Acebott needs to come up with a swarm program. Can we do that, Haipeng? Can we get Acebott to come up with a swarm program, like a spider drone swarm, and get them to collaborate with each other? Oh man, this one piece is so hard to get into. Here we go. Dancing toothless. What's dancing toothless? We're dancing together. So I think they need like at least 3 legs in order to be on the ground, right? So they lift one leg up at a time to walk. Okay, sense check. Yep. I think that's looking pretty good. Don't you think so? So this is the front left leg that I'm trying to build. So that's this one. So now I need I need 2 legs, because it's such a, if you need 2 legs, you'll have to be balanced on the feet very well, right? But because these feet, you can see that like it's pointy, it's always going to tilt towards one side. Oops. Okay. So I think I need to screw this in like this. But the screws need to come in through the back. Yeah. These screws are very tough to screw in as well. Make sure that the kids have strong fingers. All right. So this is the front left leg. So it's going to go like this. Oh, there's a nut inside here. It's looking good. Oh, what did I drop? Nope, nothing important. All right, we're almost there. I love how everybody's having a good chat with the Acebott engineer on chat. That is so cool to see. All right. What the screw is that? This little piece of plastic hasn't. There we go. All right. So that took me probably it would take me 15 minutes to do one leg. But luckily, I have done all the other legs already. So I have prepared all the other eggs earlier. But it would normally take around about, I would say about an hour or 2 hours to do all the legs, because they're all unique. Each leg, the forward left, forward right, rear left and rear right legs, they're all different. So for kids especially, it's very easy to make a mistake. So I did it pretty quickly, but I would say that normally it would take some more time. All right, let's have a look. So you got forward right, got forward left. Let's zoom this out. Then we got rear right and rear left. All right, so we got all the legs all done. Now it's just a matter of making sure that things are wired up properly. That's exactly right. Yeah. So that's a great point that someone in chat just made, is that just by making mistakes is actually going to teach kids more than just reading instructions. That's a really good point. All right. So we need to install all our steering. So right now you can see that all our legs, they're not fully attached. They're loose, and that's a reason for that. It's because we actually need to power up the motors, and then we got to zero the position of our motors before we finalize the connection of the legs. Otherwise, on the zero position, it might not actually be on the zero rotation, and then when the robot moves, it's going to go haywire and not work. So that is something that is quite challenging. But before we do that, we're going to have to wire up the robot. So let's have a look. Rear left goes into D0. Remember, the brown cable is on the outermost edge. I'm always very scared to get these wrong. This one goes into D4. D8 for this one. All right. Finally, D5. Okay, it's still looking good. All the axles are on the outermost edge. It's good. All right, now I believe we need to zero the positions. Do we? make sure wiring is connected. I'm sorry, I just separately I have a the PDF file open, so you can actually follow the PDF if you want by downloading it from the Acebott website. Okay, install the battery. It's good. So this is the battery I was talking about. I got myself some Panasonic batteries. It's called the NCR 18650B. It's a lithium-ion battery. It's not a standard battery, and also both the sides are flat, so sometimes you have to triple check which side is the positive, which one's the negative corner. Install it into the compartment. So this is positive. So hold on. Just gotta be very careful not to break anything. This one particular battery compartment is a lot tighter than the one I had before. Does it? Okay. Okay, there we are. Well, that battery was a little bit difficult to put in. Alright. Hope my head wasn't covering that too much. Okay. Batteries in. Ensuring positive and negative poles were not reversed. I don't think they were. Otherwise it will be a very spectacular... Okay, let's have a look at this. Okay, we need to get it into the 0 position. So once we turn on the robot, we've got to make sure not to turn the shafts when the power is on. So if we need to adjust the position of the zeros, we've got to make sure that we detach the motor before we zero it in. Like this. Okay. Now I'm going to plug this into my computer. Right, it's looking like it's coming alive. And then I turn it on. Oh. Can everyone still see me? So it just said that I lost connection to YouTube Live because I turned on my port, which could be an issue, but I better do this quickly then. I hope everyone can still see me. Just showing you what is going on. Oh, things are still working well. Okay. Whoa, I just heard the robot move. That's a good sign. All right. So now that the robot has moved, I'm going to set the 0 positions. Okay. Well, that's good. Thank you very much for checking for me. I'm just going to try and connect everything now. Yeah, so the program, I think it is Scratch. And the thing about these spider robots, even though it's, the 0 position is like off by a tiny bit, it's still going to be able to walk. You just have to yeah, because you got to remember, Scratch is an actual language, right? Lots of programs use Scratch. Okay, I'm going to secure this in. I think it's okay to secure it now. Nope, screw's too big. Yeah, it's pretty much the same as Scratch. I'm going to add a source here, and then you'll be able to see. So you can see sort of when I need to work on that. So it is block coding, but Scratch is a kind of block coding language. But yeah, I think it's actually a version of Scratch 3 that they're using in Acebott. Correct me if I'm wrong. Acebott, but I feel like it's using Scratch. Am I not doing this properly? Is this not the right screw for SG90 server? Oh, okay. Maybe it's this one. All right, almost there. Very fiddly. I can hear the motors buzzing because they're trying to maintain their zero position. I'm gonna make sure you don't fight the motor. Okay. If you turn it off, then you might make a mistake because the motor has to be in this position. This is the zero position, and when it's in the zero position, the legs have to built in this exact way, otherwise it won't work. So that's why we have to sort of work like this. I'll be careful not to put a screw into. I'm very scared that I'll drop a screw into the the motherboard, and then I'll be in big trouble. Or a screwdriver. What's that? Don't scare me like that. You say kaboom. Did someone say kaboom? All right, one more. I think. All right. Construction complete. Oh, no, it's not complete. You just need to put the wiring and also the top plate to cover everything up. Sorry, I've been so quiet. I've been so quiet because I've been trying to focus and make sure I don't mess this up. Okay, let's have a look at the next bit. All the wires are done. Just need to now make sure I tie all this up without stretching it too much. Just gotta be careful when you're bundling up the wires not to like cover your charging port, because I've had that happen before. I've seen students accidentally bundle this up and it covers up the charging port, and then it's not fun. Don't want to do that, because then you won't be able to charge your robot. So the charging port is in the front. I'm gonna tilt it this way, like that. Yeah, that works. Just gonna make sure that this is not too tight. This is not too tight. Oh, merge it with a quadcopter. That would be cool. Maybe you can. Maybe you can if you had a drone or something like that. I also don't want to tie it down just yet, because I want to test it first to make sure it doesn't. Well, you know what? Yeah, I'll just do it like this. I don't want to zip tie it just yet, because I don't want to, have to open it up in case something goes wrong. Hopefully nothing's gone wrong. I don't. But famous last words from an engineer, right? So hopefully nothing's gone wrong. But then as soon as you start it up, maybe there's something that I missed. Thank you, Robo Vikings. Thanks for joining us on this live stream. All right. So notice all this time the motors have still been powered on to maintain that 0 position, so that, you know, make sure that when you build it, it has to maintain that position. It would be nice if we had like absolute position on the motors that is marked on the servo motors, but it's probably asking for too much. All right. Okay, robot is turned on. Servos are installed. Now it is time to try and activate the robot and see if it works. Who's excited? Who's excited and hopeful that this is going to work? Now, whether it works or not, even if it doesn't work, I will make a version that does work, and then I will post videos of that later on. But if you haven't seen this robot in action, you can also check out the Acebott website. They have videos of this in action. But let's try to get it working today. We'll go into, it's been what? How long have I been online for? It's an hour and a bit. It's an hour and a bit. This is probably the longest live stream I've had for a long time. But also, this is probably the fastest build of the Spider Robot. Somebody tell me that I made this in record time. Let's go into Acebott. Going to load up yeah. Lesson 1, servo test. Is it servo test? Oh no, I'm going to load up and I'm going to close this. Yeah, I'll close this, and then I'm going to do a new file. Can everyone see this? Yep. I'm going to do a new program. I know it's a little bit small on the screen. Right, I'm going to test this. Uploading now. Everybody, fingers crossed. See if this robot stands up. It goes on to, what is it, standy? Standy mode. Standby mode. Okay, nervous. Are all the motors going to work? Please work. Oh, look at that. Okay, what does this tell me? It tells me that this one leg is not working. There's one leg, the shoulder is working, but the motor here is not working. So what could that be? Is it because of a loose connection? I'll go back to the zero program and try to run 0 again. Got this one elbow. Check the wiring connection. Okay, I'll do that. Okay, shoulder's working, but this part's not working. This knee joint is not working. So I'm gonna have to pay attention to that. How do I, is there a way to check the connection in the software to see what is connected to that knee hyping? Like, is there like a devices connected kind of view? Okay. I'm going to have to ask Haipeng to help me out here. Alright, we're looking at this knee. This knee connection is going into this connection here. So it feels like it is a solid connection. It really does. Feels like a solid connection. What else could it be? The thing is, I've tested these three legs because I only built this leg today. This the front left one I only built today. The other three legs I've tested last night and they were working. So, what could it be? Could it be because I'm blocking the stuff on the top, the on the motherboard? I'm gonna run it again. Okay. Power down and power on. That's a good idea. Turn it on and off again. Okay, completely powered down. Turn it on. All right, connecting. Upload. Just the thought is that the 0 position probably would be wrong on that now. Oh, it's working. Oh my gosh. It's so cool. Look at it. It's like I don't know about you, but I am scared of spiders. And this robot, when it is standing on 4 legs and it's moving, it gives me a little bit of the creeps. All right, it makes me a little bit scary. That is so cool. All right, now let's see if we can make it do a bit of a walk maybe. Wow. That is so cool. All right, I'm going to have a look at the next. Okay, move front. Activate standee. Move front. Yeah, it's very creepy, isn't it? All right, I'm going to try and move this robot. Activate standee. So, which way should I? Oh, whoa, whoa, don't slip. Okay, let's go move front. I think that's all we need. I'm glad the 0 position. Ah, hold on. You see that? Must be a loose connection somewhere. So this leg has a bit of a loose connection. See how it's. I feel like we need to turn it on and off. So that's really cool. Just going to turn it off so that it doesn't keep moving around. I'm going to try to make it actually move. All right. It's so cool. All right, let's connect it now. Let's run the upload and see if we can get this robot moving. All right. Oh, it's thinking. It's Thinking hard. Whoa! Oh, it's moving this way. Okay. Oh, check that out! See that? So it's slowly moving this direction. I'll try. I'll move it onto this side. Whoops. It's moving 2 legs at a time. Not sure if my picture's blocking the way, but it is really cool. All right, and that's it. That's it from us today. Thank you so much for joining me on this live stream, everybody, and thank you so much, Acebott, for sending me this robot to test and to play with. It's looking fantastic. I can't wait to connect it onto an app and control it. And there have been some great suggestions on the chat as well about how we can maybe 3D print some shells and make some improvements to it. Really, really awesome stuff. So thank you everyone for joining the live stream, and make sure you register, subscribe to the channel if you want to see more of this kind of content, and comment below. Are you going to be interested in checking out these spider robots? We are running some classes these holidays to build this robot, so make sure you check our website to learn more, and if you're interested in getting an Acebott robot, you can visit their website on the link below as well. Okay? That's it from me today. Take care, everybody, and I'll see you next time. Bye-bye. It's so cool. It's so creepy. Can you imagine seeing this in the nighttime? Oh gosh. I built a lot of cool things, but this is probably the coolest thing I've been able to make myself, right? So cool. So cool. Alright guys, thank you again, and I will see you later. Bye-bye. Let's make a thumbnail pic for the video. Jeez. Maybe I'll put it over this side. The leg, even though it's not working, it is still walking. I think it's the connection. It's a connection issue. But when we restart it, it works again. So just have to yeah, be aware of that the connections might be a little bit of a bit of detail. All right, take care, everybody. I'm gonna log off now. Mm-hmm.